Okay, so we are dealing in this unit with linear functions. Linear functions, and right now we're dealing with, what if we have the situation? Can we figure out a table of values that fits this situation? Can we create a graph? And can we write the rule or the equation? That's what we're focusing. So here we have the example, and we're going to go ahead and look at what we've got. We have a racer that goes 3 feet for every 2 seconds, and you got a 2-foot head start. So it doesn't matter whether you start with a table of values, the graph, or whatever order you do in. I know we need 2 pieces of information. We need the slope, or the speed. In this case, the slope is 3 for every 2. And the y-intercept, the starting amount, is going to be at 2. So once you have that information, you can start with your table. There's my y-intercept, and I'm going 2 seconds, so 3 more would be 5. For another 2 seconds, 3 more would be 8. Another 2 seconds, 3 more would be 11. So we're going ahead and we're basically saying it's the change of 3 for every 2 seconds. So that's one way you could fill out that table. Another way is, well, if it's 3 for every 2, that's the same thing as adding 1.5 every second. So if I started at 2, and then I'm adding 1.5 every second, so 1 could be 3.5, and 2 could be 5, and you can continue with that process. So it's 1.5 for every 1. So you could do it that way. Oops, that was weird. Graphing it, I probably, for most of us, it's easier to kind of break this out a little bit. So every 4 things, I'm going to have a 1. Beep, beep. And then here's seconds, and here's distance. So I'm going to go ahead and I'm going to start at 2, right? And I'm going to go up 3. Here's my slope. So we're going to go ahead and go up 3 for every 2, and then up 3, 1, 2, 3 for every 2. So here is our equation. Here's our graph. We don't need the little triangle part, but it just helps draw it. And then the equation, once again, is it's 3 seconds for every 3 meters, 3 feet for every 2 seconds, goodness gracious, times every second, added to the 2-foot head start. So here we are, we're at the situation, we have no money, and we have $2 a day. So why don't we start with our table of values. So I'm going to blow this up a little bit. And when we're dealing with the table of values, first thing you want to figure out is, we're going to find the starting place. Which is your y-intercept. And then you want to find your slope. In this case, that's how much money is added. So you're going to want to make sure that you understand what's going on. So in this case, X stands for the number of days. Oh, fish. The number of days that I'm walking the dog, and Y stands for the total money. Almost always, almost always. If there's a time, it's an X. And if there's a total, it's the Y. So now we know that we're starting out with 0 money. That's 0 when X is 0. When X is 0, that's always your Y-intercept. Always. And then it says we're growing by 2 each time. So after 1 day, I'm going to have 2. After 2 days, I'm going to have 4, etc. And yes, I realize you guys think I should renegotiate my salary at this point. So here we are. So the last one we need to look at is how to get the equation. And once again, it doesn't matter which one you do first. It just doesn't matter. You're still looking for the same stuff. I'm looking for how it starts and how much it adds. And so then we need to put that in our template that we use for linear equations. So we're going to go ahead and push this to the equation. And we know linear equations are always going to follow the template of y equals mx plus b, where the b is your y-intercept, your starting amount, your figure 0. In this case, it's how much money I started with, which was nothing. And then the m is always how much it's growing, or how the speed, in this case, it's growing by $2 a day. So we're going to go ahead and the equation can be written as y equals 2x plus 0, because we don't have any money at the beginning, or y equals 2x. Done. So the last thing we need to do is always we want to make sure we know what the slope means. In this case, the slope represents how much money you get in a day. Woo, that's fun. And the y-intercept is how much money they started with. In this case, it's me, but you know it's not really me. Because I don't like dogs, so I don't walk dogs. I know. I'm a horrible person. Anyway, slope represents how much money per day, and the y-intercept represents how much money they started with. Now let's look at if I have a situation I want to do the graph. Okay. Once again, we have to find the starting amount, find the y-intercept. Shoot. My thing's breaking, guys. Find the y-intercept, which in this case is 0. And then you're going to go ahead and use the growing. Here's the slope to graph. Or if you wanted to, you could make your table of values and then graph after you've got your table of values. It's all your choice. So we're going to go up 2 over 1. I'm going to blow this up a little bit. And I'm going to go up 2 over 1. And here is my graph.